Hello. So Josh, you should be host now. The recorder is starting and looks like quite a few people are here. So feel free to get started with Lab 8.
Let me get my screen. Okay. Get the chat open. All right, is everybody able to hear me and also see my screen share? Cool. Well, today we're going to be starting with Lab 8. So as usual, I'm going to go here to the syllabus, get everything from here. And we're going to be looking at matrices. Oh boy, linear algebra, my favorite. I actually like linear algebra, so not a big deal. Here we go. All right. So let me set this to the light mode because I think there's going to be some equations here. We're going to need the text files that are included. So make sure that you have them downloaded and put them in your bay somewhere. It could be anywhere. I have them in my lab folder on my machine, so I'll drag it in when we need it. So we're looking at the treasure1.txt that we've seen before. Looks like this. As we have handled the treasure maps in the homework and in the labs, we want to look at the row and column given by each cell. So this would be, row 3, column 4 is telling us where to go. And that tells us where each, where the directions are going to be for the treasure. And when the cell is the location that is being told to go to, i.e., I can't find it super quickly, but when this would be 1, 1 saying go to the cell we're in, which is row 1, column 1, then you found the, let me just mute everybody.
Honestly, it's there. My resume is not impossible. I think I'm doing a good job.
Honestly, I'm not sure, but anyway. Okay, so how can we represent this file we have here? Well, we have it as a text file, which is easy to do, as we'd seen last time. But how do we want to represent it in memory? Well, we can use the lists in Python to store this as a matrix. It's something we can do. So this is, I believe, the same code we had last time. So let's get it up and running. So I have treasure1.txt, put everything in there. Get rid of the row and column, just the labels. So C1, C2, R1, R2. That's what these are for. Okay. And we'll see. Let me get rid of these. This is running stuff. Okay. Okay. So as we see in our matrix representation, so what let me see. Visualizing a matrix can look kind of tricky. So let's get my annotation tool out. And we have, ooh, that's weird. Why did I do it twice? Huh. I don't know why it keeps doing that. We have rows and columns in our matrix. And what would be position 0, 0? That would be this right here. And how would we access that in, say, the Python syntax? Well, we have the row and the column of whatever thing we're looking at. So if our matrix is M and we want position 0, 0, we would look at it that way. And that is shown right here. So we were looking at this in the last exam. It's kind of funny to think about. It's been a week since our last lab, but in the last lab we were looking at this. We want to get the value of the next one we're going to be looking at. And how do we look at that? Well, we have our treasure map, which is a list of lists. We want to look at the row -1 and the column -1. This is the matrix representation. So the reason it's -1 is because we count from 0. So if I'm looking at, let's say, the first one, the first position, which would be here, in what we would normally count, this is 1, 1, right? Well, if I have 1, 1, that would go to 0, 0, and that gets me the position as 0, 0. So this is one we looked at last time. So I'll ask, are there any questions on it? There are some intricacies to what's going on here. And we're going to do this example again with another input, but are there any questions on what we already have on the screen? Okay, well, either everybody's following completely or everybody's completely lost. So either way, we have 100% agreement on that. Let's put it that way. So I've already ran this once, but I'll run it again. What do we have as the treasure map? Well, it's whatever is in treasure1.txt. So it's this here. We get rid of the row and column, and we run our algorithm here. And that's it. So let's consider the file in treasure2.txt. Very similar to what we have here. It's the same format, more or less. There's a dash instead of just spaces, and the C's and the R's are capitalized. Other than that, the numbers are also different, but same format. So let us take our treasure2 and see if we can do the same thing. All right. So what do we need to change about our code here that would let us get our other treasure map in there instead? So if I would want to run this, so we change the file name. Yep, I need to change this. Is there anything else I need to change? Oops, I think I put the same thing twice. Is that good? What's different from what's going on here? Well, the numbers are fine, the commas are fine. What about the symbols for row and column? So R1, R2, R5, whatever, those are all the same. C1 and C2, these are all capitalized. Do I need to do anything different for those? Where in here, there's somewhere in here that I handle getting rid of this entire first row. Where is that? Which part of my code gets rid of the entire first row? Yes, it's right here. So because we're getting rid of the entire first row, it doesn't particularly matter what is going to be there. Could be spaces, could be dashes, could be whatever. So we're getting rid of that. So let's run it. All right, we're running with our other file name, putting that into our treasure map. And let's see if our treasure map looks any different. So last time it looked like this. Let's see if the new one loaded in appropriately. Looks like it's different. It's not the same one. Okay. So our same algorithm worked for a different text file. We stored the treasure map into a matrix. It's a list of lists. So our treasure map is a list, and every element in this list is itself a list. You got list 1, oops, list 2, list 3, so on and so forth. So it works just fine. Okay. Well, let's do something a little more complicated. Let's do matrix multiplication. So how do I do matrix multiplication in just regular linear algebra? What's the algorithm? Meaning, if I were to do this on paper, how do I multiply the matrix A by the matrix X? So this X here is a 1, 2, 3, 4, 5 rows by 1 column matrix. It's a special kind of matrix. Somebody know what it's called? We have a cool matrix. Yeah, that's a good one. It is a vector. So A is a 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. 5. Ooh, that's horrible. Sometimes I can't draw very well. 5 by 5. And here we have a 5 by 1. Now, when you're doing matrix multiplication, you can't always multiply two matrices together. General rule of thumb, these two numbers need to be the same. And the result is going to have the dimensions of what's left. So if we want to multiply AX generally into B, so AX equals B, something like that. What's the procedure to do that? How do we start? Before we can write the code to do any given task, we need to know the steps for actually doing that task. So what are the steps for doing the task of matrix multiplication? Well, if I have a general matrix A and a general matrix B, and I'm going to multiply them together, and I already know I can because I checked the dimensions like I did just earlier. So I want to multiply those together. This element right here, let's call it 0, 0 or 1, 1, whatever you want. How do I get that one? What's this element here? Because this whole procedure is an element-wise operation, meaning that the result is defined bit by bit. So this bit right here comes something from this part and something from this part. And this part right here, same thing, something different from this part and something different from this part. So how do I get, let's say the first element, 0, 0 in the result matrix. So it just says multiply each individual term on the first row within matrix A with the first row in matrix X and add them. Okay. So that's specifically looking at these. That's fine. So first row in matrix A. First row in matrix A, and you say first row in matrix X. All right. And then multiply each individual term and add them. Oh, you say, wait, not add. Okay, then what do you do? List them in a new matrix. Okay, pretty close. If I have a general matrix like this, the element here is going to be the first row. I'll make it a different color. The first row and the first column. And what I'm going to be doing is I'm going to take this element here times this element here. And I'm going to add that to this element here times this element here. And I'm going to add that to this element here times this element here. And I'm going to add that to this element here times this element here. So it would be like 4 in this position times 0.59 here, because this is our matrix is only one, it's a vector. So we only have one thing to work with. So I would do 4 times this plus 1.5 times this plus 0.7 times this, and so on and so forth. So I do all that. And because our result is going to be a vector, now I have the first term. What's the, so that's the first term. If the first term is this row times this column, and there's only one column, and this is the dot product of this row, this column, and that's going to give me the first element here. How do I get the second one? What's the second element here? So if the first element here is the first row multiplied by the first column, then what is this element here? Now keep in mind, this is a vector, so there's only one column. There's not more than one. So I can't do much more with X. It's going to be the same thing for X, but what am I going to change about my A? Second row, correct. All right, so that's the procedure. Is the whole thing is element-wise, meaning let's pretend that this isn't just a vector. This is the whole matrix. That this element here is defined by this row times the first column. And this element here is the first row times second column. And this element here is first row, third column. This element here, second row, first column. And the whole thing just follows. So that is what's called an element-wise procedure. So let's look at how to code that up. Okay. So we need to store the data we have for A and X. So we do that with our list notation, list of lists. You got your first row, second row, third row, fourth row, etc. And our vector. Okay. How are we going to multiply these together? Well, first thing I'm going to do is I'm going to take my result and I'm going to just make a matrix and I'm just going to fill it up with zeros. Okay. So I'm going to fill an entire matrix up with zeros. And what's the size of this going to be? Well, it's going to be a list. And it's going to go from 0 to the length of x. So what's the length of this? We got 0, 1, 2, 3, 4. So it's going to be the same size as this. Okay. After that, we're going to enter a for loop. Now, what are we going to do in this for loop? Well, we're going from 0 to the length of our first matrix in steps of 1. Now, if I have a matrix like this, now this one just so happens to be square, but what's the length of this? If I were to run length of a matrix, what would it give me? Would it give me the length of this, which is 5? So you got 4, 1.5, 0.7, 1.2, 0.5. Would it give me the length of the list inside, or would it give me the number of lists held in the outer list? It's important to know. Yes, it would give you the number of lists. This is the number of rows. And if I wanted the number of columns, I would just say, give me the length of the first list inside of it. Okay, so we want to print it out. And then what are we going to do? We're going to print out the other one. And here we go with the element-wise operation, like I said. So if I want the result, it's going to be whatever is currently in the result we're looking at. So we're building up our vector. And we have, well, let me make it a different color. So we have our matrix. We have our vector and our result vector. And we're building it bit by bit. So what goes here? Well, it's the first row times the first column, which is everything. So it's going to be this part times this part plus this part times this part. And that's what's going to go in here. So we're going to start with 0. And I'm going to say this element times this element. Add it to what's currently in there. Currently it's 0. And then add on to that this element times this element. And then add on this element times this element. And we're just going to keep doing that. That's what's right here. We're going to go through the whole thing. And we're going to build that up. Okay. Anyone have any questions on this line here? Because this line is what's doing all the work. Okay, well, let's run it, see what it does. Okay, so we have our matrix A, we have our matrix X, and we have our result, which I'll call B for the moment. It is also a vector. It's the same dimension as what we have here. No surprise. What is this element? Well, it's 4 times this, plus 1.5 times this, plus 0.7 times this, and so on and so forth. We could do the calculation manually. If I bring up my calculator, I won't share it. We'll just have to trust that it does what it says. Is anybody in doubt of how this element here, 5.0, here, I'll even say it this way. Print result. Here we go. Is anybody confused on how we computed this result matrix? Because this is, even though it's a vector, and we'll see in the very next example, a real example of this, but even though it's a vector, it's still a matrix. All right, this is a really simple example, so it's important that if someone doesn't understand the element-wise, and why do we call it element-wise? Well, this is a doubly nested for loop. If I have a single for loop with element 1, 2, that's horrible. 2, 3, 4, 5. If I'm doing an element-wise operation on my list, well, what's the first element? It's this one here. What's the next element? It's this one here. What's the next element? It's this one. Cool. Now, what if I have a doubling, or a doubly nested loop? That means not only do I have a list, but I have a list of lists. So that means I'm going to be going for this element and then this element, so on and so forth. Well, that's how we build it. I don't see any questions, so let's try to do this for a real set of matrices. All right, we have the scaffolding we want here with the comments saying what we want to do. We want to say matrix A times matrix B equals matrix C. Let's calculate matrix C. So what do we need to do? Can someone tell me the code or the procedure to read file a matrix.txt? And you don't even have to say the exact code because it's kind of hard. You can even tell me where to scroll. Where do I need to go that might have what I need in order to make it happen? How do I read a file? Okay, you want to say a matrix is open. You want to use the open method. Okay, very good. And what's the file name? Well, it is a, it's what's listed there, matrix txt. And we want to open in read mode. Very good. The R is for read. And we can copy this. We'll call this B matrix. And we're going to say this is A inverse. Does anybody know? So here's a question. I've got a matrix A and I've got a matrix B. So why do I have matrix A and matrix A inverse? That's kind of strange. For the identity matrix, I see what you're trying to get at, and that's close enough. It's because matrix B is the inverse of matrix A. And what does that mean? It means that if you take matrix A and matrix B, multiply them together, you should get the identity matrix. All right, linear algebra, super fun. Okay, so we've opened a file, and we've opened another file. Is this what we want to do? Are we good? Are we done with looking at the files? I don't know. Let's look. What happens when I print a matrix? Interesting. It prints a text wrapper. Why is that? It's because this is a file stream. So you want to close the, yeah, we do definitely want to close them. Let me just copy it. We had it up here. Yep. Okay. Definitely want to close our files when we're done. But the thing is, we opened our file. We opened our A matrix.txt. But is that really what we wanted? Well, I don't know. When I printed it out, kind of had this weird, what the heck is this? I'll even do print type. Can someone tell me what the type function does? This one here. Type function will tell me the type of whatever object I'm looking at. So I'm looking at a float. It will show me that it's a float. I'm looking at an integer. It'll show me an int. But I'm looking at our A matrix, and what is it saying? It's looking at a text wrapper. That's kind of strange. Is that what we wanted? Is a text wrapper what we want for our matrix? Is this thing here? Is this a text wrapper? Curious, right? I'll open up the file itself. Does this look like a text wrapper to you guys? No. Agreed. I don't think it looks like a text wrapper either. Now, was there a point in time where we read from a file and put the data in that file into a structure that we wanted to use? Because that's what's happening here. Instead of putting the data into a variable, we're putting the actual file into the variable. We're saying, hey, here's a file. Cool. All right. Change the file name /type. I don't think that'll help us much. I want to look at the individual parts of what's in the file. We did this before right here. When we were doing the treasure map, we did the same thing. Because watch, I'm going to print the treasure file, and we'll get the same thing we just got. See, we have the text wrapper thingy. It's kind of strange. And we have the same thing here. Same mode, different file name, but this doesn't do us much good. Thing is, we have our treasure map. Like right there. So we have the data from our file put into a variable. So we did that here for our treasure map. We want to do the same thing for our matrix. So how do we do that for our matrix? All right, let me ask it this way. What are the steps that happen right here? Well, we make an empty list. Why do we make an empty list? Because we want to store our data in a list. Yes, we create an empty list for it to fill in. That's correct. And then what do? We open our file because that's where the information is we're going to need somehow. Now, how do we get that information? Well, we have to go through the information line by line. Here's the first line. Here's the second line. Here's the third line, so on and so forth. So we say for each line in the file, here's what we're going to do. I'm going to take my empty list and I'm going to append a new list to it. What's that list? Well, I want to take my line, and what's the actual one? It looks like this. Here's the line. I would like to get rid of all the white space and then split on commas. Now, what does it mean to split on the comma? It means every time I see a comma, I want to break it up. So I have C1, that's 1, C2, that's 2, C3, that's 3, and I can change this if I want. If I were to do this, I've removed a comma. So you see how this list here, well, I guess we're doing treasure 2, but I'll make it treasure 1. You see this list here, it says C1, C2, C3. Well, I removed a comma. And as you see, no pun intended, we have C3, C4 as an element. So put the comma back. We have C3, comma, C4. Okay. So I'm going line by line to get what I want. Our matrix file looks like this. Very similar. A little different, but very similar. So this code here is going to be very useful to us. I'll go ahead and copy it. All right. So this is the copied code. Excuse me. What do we need to change about this to make it do what we want to do? Excuse me for a sec. Okay. What do we need to change? Well, the first thing I would say, I'm going to call this a file. I'll call it a file. And that way we can know that this is the actual file rather than the matrix itself. Okay, so now what? What do I need to change? And this is the last thing in the lab, so perfectly fine to take the rest of the time to do it. Treasure2.txt. Okay. Yeah, we're opening a file and I don't need the treasure part, so I can get rid of that. What about this? Do I need to do something similar for our matrix? Do I, what kind of, okay, assign it to a list. Sure, yeah, that's fine. This will be our A matrix. What's the matrix? Well, it's a list. What kind of list is it? It's going to be a list of lists. All right. I don't need to print that. All right. So I have an empty matrix and I have an open file. Okay. We'll even say we want to close the correct file name. All right. Now, let's look at our for loop here. Do I need to change anything about, so this is the variable. I can call it whatever I want, call it X, but I'm going to call it line. And this is the thing I'm iterating over. So do I need to change anything here? For line in a file, correct. We need to change this to this. Okie doke. Is there anything else I need to change for that part? Looks fine to me. A file. Okay, yeah, we're moving on. All right. So Hunter says to put a file. Now this is very interesting. This is not what we want to append to. But can someone tell me what the problem with appending to the thing we're looking at might be? Let's say I'm going through a list, right? And every time I go through an element in my list, I'm going to add that element to the end of the list. Yeah, that would change the file. So that's not super great. But I mean, I knew what you were getting at. Instead of appending to our file, we're going to append to our empty matrix. All right, we're going to append to this matrix something. Now, what are we going to append here? Well, what goes in here is this line here. Thing is, I need to have my 4, 1.5, 0.7, blah, blah, blah as separate entities. So I'll go through this line and tell you in detail what each bit does. And then I need you to tell me, you guys to tell me what I need to change. So what this says, I'm going to make a variable going through this iterable. And whatever that is, I'm going to make it a string. Okay. And what that thing's going to be is I'm going to take the whole line. I'm going to strip any white space out of it. And then I'm going to split on a comma. So get rid of all the white space. And then every time I see a comma, make a new element. Split the string is what it's doing. Okay. So when I see this, I'm going to get rid of all the white space. I see C1, that's fine. C, that's fine. 1, that's fine. Comma, split. So I have C1. C, that's fine. 2, that's fine. Comma, split. So here, I want to do the same operation, sort of. So explain in English what I want to do here. And someone said, can we split based off of a space? Yes, we can. Can we split it? Yes, we can. So strip gets rid of white space. In our instance, I'm not exactly sure because it's possible that there is more than just a space. There could be a tab here, but we'll find out very quickly. The split function works on whatever you hand it. So if I were to say split on colon, then every time it finds a colon, well, let's just run it, see what it does. Print the matrix and close all of our files. I'll comment that out. Okay, what did that do? Well, we went through the line. We got everything we wanted and we split it on the colons and there weren't any colons. All right, what if I split instead on period? Because I know there's period there. Well, we got a whole bunch of stuff. 4 and 0, 1. Now, what if I handed it? Well, here's the real question. What's the symbol between 4.0 and 1.5? It appears to be 2 spaces. So let's try feeding it that, which, yeah. Let's see what that does. Does that look good? Someone says sure, which is very enthusiastic. Let's see. The first row of our matrix, there's a space before every element. Are you sure? What's the first one? Well, I don't know. Let's print it out. What's the first element? Print a matrix 0. Well, let's do that first. All right, we get this row. And what's the first element in this thing we just printed out? It is that. Now, here's the kicker. What kind of thing is that? Is it an integer, a float, or a string? It is a string. Very good. We don't want it to be a string, do we? What do we want it to be? a float. So what might I want to change in this code? Instead of putting it as a string, it puts it as float. Yeah, I want to change this part. And just to make sure, I'm going to say print the type of this. It says string. I'm going to change this to float. And there we go. All right, now I have my matrix represented as a list of lists. And what's inside of those lists? A bunch of floats. Looks good to me. All right, I don't need to print that. Don't need to print that. And I can just copy and paste because that's the beauty of recycling code. We'll call this the B file, just because I know it's the inverse matrix, but I'm going to call it the B matrix. Just it's easier. Alrighty. And the file name we want is this, A inverse. Okay, let's run that. Well, if I run it, we're not printing anything, so I can't really see anything. Create a destination C matrix. Create a destination matrix C matrix. Okay, C matrix is what I'll call it. What kind of thing does this need to be? Is it a integer? How about a string? Yeah, the empty string. Let's go with the empty string. Is that what we want? We have our matrix A, our matrix B, and our destination matrix. What kind of thing is this going to be? Is it a integer, a float, a string, or something else? Well, let's put it this way. I have my matrix A, my matrix B, and I'm going to have a matrix C. Are these three things the same kind of thing? Is A the same kind of thing as B, the same kind of thing as C? Okay, the answer to that is yes. So whatever kind of thing I made for A is going to be the same kind of thing I need to make for C. So what kind of thing did I make for A? A list. That's correct. So for C, I also want to make a list, and it's going to be empty. Now, the thing is, before, we made a whole bunch of zeros, and we want to do the same thing here. How many zeros do I want to put in here? Well, let's look above. Here's where I populate with zeros. This is the same thing as my C matrix. I say 0 for I in this range. What is the range? Well, it's from 0 to the length of the vector. Okay. That's because we have a matrix and a vector, and the result is a vector. So I want to fill this whole thing up with zeros. Cool. But now I have a matrix. Oops. A matrix, another matrix, and a matrix as a result. So I need to fill this thing up with zeros, but how many are there? 25? How do you know? It is 5 by 5. Yes, it is. How do we know it's 5 by 5? Well, I don't believe the exercise requires us to know this, but as I said before, right now I have a 5 by 5, which is A, and a 5 by 5, which is B. The dimensions of what goes here is going to be this by this. The only way I can multiply two matrices together is if these numbers are the same. So that means I could have a 5 by 5 times a 5 by 2, or a 5 by 1, which is what I have above, and the result would be a 5 by 1. So in our case, we have a 5 by 5. So we want to fill the whole thing up with zeros. Okay. Instead of hard coding the number 5, what we're going to do is say 4. I'll just copy because copy is good. Here. Now this is going to give us a vector. And we want to be an actual matrix. So we're going to fill that in with, I think what we can do is we can append this for I in range from 0 to the length of a matrix, colon, and that. And then here we need to change this to be B matrix. Well, really what we need to do is put that 0, but it wouldn't matter because it's square. It's 5 by 5. Okay. And that should print out, or that should give us the completely filled out empty C matrix. Let's print it to make sure. The length is the same, correct? But just in case you, we have a nice little example here, but in general, not always going to have it. But it looks like we got what we want. We have a 5 by 5, 1, 2, 3, 4, 5 zeros, and then 1, 2, 3, 4, 5 of those. Cool. All right, we have an empty result matrix. All right, let's print out the first one. Print a matrix is that one, and then copy inverse is this one, and then what we want to do, and I could format this to make it print a little nicer, but I'm low on time. What we want to do is perform the multiplication and put the result into the C matrix. How do we do that? Well, we just copy the code we have here. What are we doing? We're saying go from 0, same thing we're doing here, from 0 to the length of A, and from 0 to the length of B. So it'll be this, oops, and this. So both of those are 5. And then I'm saying put into my result. And this is actually going to have I and J because it's not just a vector. But what's currently there? In fact, I'll just copy the whole thing. Plus A matrix, IJ, B matrix, IJ. So I'm saying add 0, 0 times B 0, 0 to the current result, and then do 0, 0, 0, 1, and then 0, 0, 0, 2, and so on and so forth. Okay. And then finally, we want to print the result out. Print C. Okay. Now, what we want to have is the identity matrix, because A times A inverse is going to be the identity matrix. Thing is, this is really close. You see there's something close to 1, something close to 0, something close to 0, something close to 0, so on and so forth. And then something close to 0, something close to 1. And that continues on. Because there's float arithmetic in here, I could round it correctly to make it look super nice and print out super nicely. Then it would actually be as close as we could get to the identity matrix. I wish I could make this print nicer without having to do a whole for loop, but it is what it is. So that's what we have. A quick matrix multiplication. Get the first one, get the second one, fill in zeros for our C matrix, and then element by element, take the result, add it, this one times that one. Elementwise operation. Yeah, we could round to 0 or 0 decimal places, and that would do it. I think the round function is something we have. I don't think it's in math. So there we go. Which is as expected, the identity. So we have the first one, second one, third, fourth, and fifth. Okay. That's the lab. Let's look at the homework. It's going to be very, very similar. Here is another matrix and a vector. We need to do everything listed here. It's pretty simple. You're just doing what is said to do. Okay. And as I was saying, here's a matrix and another matrix. What is the dimension of what we're going to be looking at? Well, what is A? How many rows? There's 3 rows and there's 2 columns, so 3 by 2. Can I even multiply these together is the question. So I have a 3 row by 2 column matrix. And here I have 2 by 3. Can I multiply these together? Yes, because these are the same. And what's the dimension going to be of the result? Who knows? If only I had mentioned that previously in the lab. Okay. So you're going to do the thing we just did, except with this as the, here's the files for that. Okay, that's it. It's a dense but short lab. Any questions? Yes, it will be 3 by 3. All right, well, everybody seems to be okay with it. So I'll let everybody go. And I'll have it's been a week. I'm all messed up. I'll have the labs for last Wednesday graded by Friday. Okie doke. Thank you very much.